Ah, where's my camera? Damn you! There we go. That overlay had the camera disabled because I'm an idiot. I was experimenting with having the camera hidden because, as you can see, it kind of hides part of the inspector. But we can just hitch up this and it'll be fine. Um, Good morning, everybody. It is time for another round of Unity tutorials. Today being part 1 of a series on procedural generation using the factory pattern. Today we're just going to go over what the factory pattern is, how we can do it in Unity, and an example that we can use to build on. So we will just start now. The factory pattern is incredibly useful. There are loads of uses for it. It'll creep into any kind of development you will do. The factory pattern is ubiquitous. It is one of the one of the four main patterns that you'd probably use as a software engineer. And it is what it sounds like. It is a class or a package of classes that build other classes. They are a factory for creating other things. So why is that a good thing? Why is that important to do? Why can't you just do it yourself? Why can't so you have, for example, we'll do a Unity example first. For example, I'm saying example a lot. We'll do a Unity example first. Say you want to create a character object, a player object, for example, and you have all this data that you can use to create that character. It might be a character that has multiple different power-ups or multiple different abilities that you can select on a menu. You would give the user a UI that would let you choose your character stats or whatever, and then when you actually go into the level, you will want to create that character. And what you can do with the factory pattern is you can go and say, I want a factory that will build me the character. Here are the things that it has, and you can create the class to know that if it has X power, then you need to set this, and if you have, and you build the class around it, and it will output what you want, in which case this would be a game object. That's one of the naive ways of using it in Unity. There's a whole other software development thing on top of that we will go into today. The thing is, like all these patterns in Unity that I'm going to go through for this example, last series we did was the Singleton Pattern. The Singleton Pattern in Unity is a little bit different from your standard software engineering pattern because Unity likes to be special. So in a similar vein, the factory pattern in Unity can be a bit special. One of the key parts of the factory pattern outside of Unity is the idea that the classes that you are building are hidden behind interfaces, and only those interfaces are exposed outside of the factory itself. All the other meat and potato classes are internal. Because the whole point of the factory pattern is that the factory is your is the thing that exposes the developer's ability to create those classes. Whereas with Unity, your end goal is generally a component or a game object, and you can't make those internal. You have to make those public. So again, Unity has this weird quirk where one of the key foundations of the factory pattern is that it doesn't really do what the factory pattern is supposed to do. but we can still utilize the pattern itself to do some cool stuff in Unity. So we're going to start off with that idea of building a game object. Now, normally what you would do with is you would create your object in the scene, you would build it up, and then you would create a prefab of it, and you would have, for example, the game, the example I gave there with the player spawning thing, you would create a player with a prefab, and you would spawn the prefab. What we can do is something a little bit different. We're going to do procedural generation. Now, procedural generation, because it's a heavily data-focused task, means that it is well suited for the factory pattern. So what we're going to do is we're going to build a we're going to build a grid of objects, and that grid of objects will be our map, and it's going to be procedurally generated using the factory. So first off, we're going to create 2 or 3 different objects, just blank squares with different colors. We'll put prefabs in, and we will do a basic factory pattern that will build us something. So we're going to create a 2D object. It is a sprite. We have no sprite there. We're going to add our UI sprite to it. We'll zoom in on that. You can see it's very, very small. Because the camera is very, very small, we will just zoom in on that. Make it a little bit bigger on the screen. So that is going to be a tile, our basic tile. Our white tile. We are then going to take this tile and make it a black tile. We will make it black. Just going to create some basic tiles with different colors. Create a yellow tile. And a green tile. Yeah, we have 6 tiles. They all have various different composite parts. And we're going to create prefabs out of each of them. Now, this is Unity 2020. We could make these prefab variants, but we're not going to for now. And we're going to remove those from there, and we're going to create a world builder. And we'll create a component called world builder controller. This is going to be the thing we are going to tell to build the world. This is not our factory, this is a controller. And again, all of the code that we're writing here will be in the description of the YouTube video. I think the GitHub link is in the info below the Twitch video. I could be wrong about that. If it's not, I will actually add that. Let me just have a look-see. Also, for some reason, has that updated the title? I just realised that Twitch hadn't updated the title despite me explicitly changing it. Yeah, it's right. It's right. It's just the mod page was wrong. I just needed to refresh it. Cool. So, World Builder controller. we need to do something with this. So what we're going to do is we're going to have a public void build world, and it's just going to be empty. Because what we're going to do in here is we are going to create a factory, and that factory, we're going to tell it what we want in the world. And as we go along, we're going to add properties to this, etc. So we're going to create a new folder called World Factory. I'm going to create a new class in here, and we're going to call it World Factory. I'm going to take out the namespace. So this is the factory that we're going to create. We also want to add in some data to it. So we're going to add a new class here called World Factory Tile. And we are going to keep the World Factory namespace just... What should we call this namespace? We need to call this something other than World Factory because we don't want to do World Factory.World Factory. World Generation. We'll rename the folder to that. We'll actually just, because it's going to automatically give us that, we'll just call our namespace that. I can't be arsed changing it. Okay, so internal class World Factory Tile. So this is how we keep the World Factory Tile hidden. This is what the factory pattern is. What we'll end up doing here is we'll also have a public interface called iWorldTile, and it will implement that. So outside of it, you will see the interface. And what we're also going to do is we're going to make that internal, and we're going to do public interface iWorldFactory. So I'm going to call that basic World Factory, because the whole point of the factory system is that with interfaces you can change what you're building. So we're calling this basic World Factory because we're just going to build a basic world from it. Later down the line, what we might want to do is create a second factory. For example, if we're doing a different biome of our world, like for example, we might want a biome that's entirely blue and green tiles. And so we will create a basic World Factory, or we'll create another World Factory called Blue and Green Biome World Factory. And it will do some other stuff. It will be a bit more in depth, and restricted, etc. So we need to figure out what we're going to do. So we need an iWorld factory. All of the properties of the factory will return itself. That is one of the benefits of the factory pattern, is that you can chain these up. So iWorld factory will be grid size, int width, int height. Name these properly. So one of the first things we're going to do is we're going to set the grid size. What we're also going to do is Because we're not going to care about connections or anything like that. We're just going to build a grid of things. So really all we need now is that add tile. I don't want to call it tile prefab because you're not adding a prefab. Add tile. Prefab's a good word though. It's just unfortunate that it's got a meaning in template. And we'll just give it an ID. Right now, that's all we care about. Actually, we're going to give it a probability. So this is going to be our basic factory. So what's going to happen is in here, return this, return this. So what we're going to call this is private class tile template and that's going to be the data that we're adding to this. Actually, rather than add tile, create tile template I think is probably a better one. So we're going to have a list what we also want to do is the final build. So list I world tile build world. That is the only thing that doesn't return itself. It returns a list of I world tiles. So as you can see, that's not that. What we're going to do in here is a bunch of other stuff. Ooh, that's another thing we want to do. I world factory. One of the things about procedural generation is that you want to be able to set a seed. So random RNG new random. So when we build the factory, you don't have to call any of these functions. None of these functions are required. What we're going to do now is in width equals 10, in height equals 10. We'll just give them some default values. So for some reason I put width instead of width. So we're not going to do anything. We're just all these functions do is they store data in the factory, and then when we go to build world, that's when it does the meat of the work. And what we'll do in set seed is we'll do RNG equals new random. Is it taking an int? It's taking an int, not a long. So this is us setting up the factory. We're giving it the ingredients it needs to make a world. We're giving it tile templates. We're giving it grid sizes. And inside this we are doing we're giving it a property we're just saving it like that. We've got no other details in here except for the ID. Actually, we'll do that. So what we're going to do is we're going to loop through, and that's what we also need to do. Actually no, int x yeah, so those are the four properties we need. We need its index. Actually, saying that, we don't need an index if we have an xy. The xy will determine its things. The type ID will be the ID that we send in here. So what we're going to do is tile templates, add new tile template, and what we're going, this is, the factory has been set up. The only thing we need to do now is write the build function. So we have what we need. We have our random seed. We have the height and width of the grid. And we have the templates that we're going to use. So we're going to look through from 0 to the width and 0 to the height. We're going to create our grid of things. So you might be wondering, why did I create all those prefabs? Those prefabs, the factory does not know about them. The factory does not care about them. One of the things we could do in the future is pass those prefabs in and have the factory work on those. Generally speaking, what you want to do though is to keep the data and the game objects separate as possible. What we'll eventually want to do is when we create the prefab, we will send in an iWorld tile with all the data bundled inside it that it can get access to. And so we will have a component on each of the prefabs which will consume any extra data and metadata that we put onto that. And that will include the X and Y position. So things like that are considered metadata. So what we will do is, in build world, we want first of all to create a list of world tiles. Call that world. And we will create world tile. It's the non-interfaced version, but because we are inside the assets world generation namespace, we can do this. We have access to the raw class. Because it implements our world tile, we can also add it to and this is where we get the random generation. So what we can do is we can create a thing in here called get next type ID. And that will be a private int and that will roll on the table. So what we do here is rng.next, and we have a min value and a max value. So the min value is going to be 0, and what we're going to do is take that list of tile templates we're going to take the sum, we're going to use link here, we're going to sum the probabilities. We're going to go from 0 to the maximum probability. So if we have 5 items on there and they all have probability of 10, that will be rolling from 0 to 50. If we have 4 items on there and they all have a probability of 2, we'll be rolling from 0 to 8. That is how we're going to roll on this table. We're going to take the maximum number of things and roll a D, whatever that is. I'm going to call that roll. How do we figure out which one to do? Well, what we do is we take the roll and we go through the list of tile templates. Now, I know you were going to say this is not efficient if we're doing this every time we build, but we are only doing that once. So what we're going to do is we're going to take this out and we're going to private in maximum probability. And what we're doing is when we go to build the world, we'll set maximum probability equal to that. Now, in the future, that might need to get calculated every time we get the next type ID, because we might be rolling on a subset of that. So we may need to pass this in, but we're not doing that just now. We'll cross that bridge when we come to it. So that is our roll. So I need to make sure that this works in my head, because I have code that does this already and it's a while since I wrote it, and I'm not going to go back and get it because we want to do this as part of the tutorial. So if this breaks, if this doesn't work properly, go back and fix it. Because it's one of these ones that's this is what I'm about to write is susceptible to off by 1 errors. Why you need to be careful with this. So what we're going to do is we're going to take the roll for each in tile templates. Helps if I can spell tile templates. So we're going to go through each one. We're going to roll minus so here is where the off by 1 error can come in. Is it when it's 0 or is it when it's less than 0? So is it less than or equal to 0 or less than 0? This is where your off by 1 error can come in. So let's think about it this way. We will create ourselves a fake table in the comments. We will have ID 0 with a probability of 10. We'll have ID 1 with a probability of 5. And an ID 2 with a probability of 7. With the total there being 24. 24? 22. Can't count. This is also a problem. Now let's say our roll is 12. We go through 0. 12 minus 10 is 2. 2 minus 5 is minus 3. We return 1. We roll 10. 10 minus 10 is 0. Do we return that? The roll of 10 is really an 11. When you think about it. So if you have a probability of 10, you're only rolling from 0 to 9 if you have a total probability of 10. So that 10 will never come up if you only have that value. If that's the only value in your list, 10 will never come up. It will be 9. So on 10, what we actually want is 0 minus 5 is minus 5. Return 1. You want it to be less than 0. And we'll do that again. So we'll roll the minimum, we'll roll a 0. That is correct. So what is the total? So the total, you will never roll a 22. So if we roll a 21. Now, what I'm doing here is thought experiment tests. In a decent production environment, you would write these tests as automated tests. Automated testing is beyond the scope of this tutorial, but understand that this is the kind of process you want to be thinking of. You want to be thinking of edge cases and extreme cases and average cases and all that kind of stuff. So it would be, so just a little bit of background on automated testing. You would set up your data like this. This would be your data bank that you would put on your testing. And rolling 12, rolling 10, and rolling 0 would be your automated testing functions. And you would do roll 12, expected result 1. Roll 10, expected result 1. Roll 0, expected result 0. Roll 21, expected result 2. And every time you built, you would do that to make sure that you didn't screw it up. So again, we'll work through this as 21 minus 10 is 11. And then we will do 11 minus 5 is 6. And then we'll do 6 minus 7 is minus 1, which is less than 0. So that's our worked out So this is our work through test data for and I'll leave that in a comment. The only problem now is that what happens when we get through all the list and we get to the end? Well, we have to throw an exception. Because it shouldn't be there. It should never get there. We have to throw an exception. And what we'll do is So what we'll do here is we'll say this is the roll, this is the maximum probability that it was set at, and this is the sum of the tile templates that we're rolling against. So it will throw an exception if it somehow rolls out with the tile templates. So this is the meat and potatoes of our procedural generation right now. We take the RNG, the random, with the seed. So random is just a class that's built into C#, it's built into .NET, that does random rollings. There is a Unity, so Unity engine .random. You can do that. It'll do floats for you, it'll do ints for you. For procedural generation, it is much better to use the random class because it's easier to set the seed. So you can set the seed there, but it's deprecated. It's deprecated for some reason. Use init state function or random.state property instead. Apparently, I'm just going to check this for a moment. So what is in random.state? Unity, what? What? This is why we use the random class, because Unity, what the fuck? Is that a placeholder? Is it not finished yet? I mean, maybe you can reflect into it. I don't know. We're not touching that. This is why we don't touch the Unity random stuff. we use the built-in .NET random class because more than likely, having just seen what we've seen here, it's probably not likely that Unity's using the random class behind the scenes, but I'd like to think that they would. Anyway, the random class is the meat and potatoes of our procedural generation. Now, random isn't random. You don't know this. It is a core part of computer science that it is incredibly difficult to get actual random numbers. But what we can get is called pseudorandom numbers. And that is a mathematical pattern that steps through one after the other that gives numbers in a wide enough range and in a random enough pattern that it appears enough random for our needs. Not random enough for cryptography. There is an entire different set of generators that you will be using for cryptography, but because we are using it for procedural generation, we don't need to use those special ones. Even those special ones are still deterministic. They are not entirely random, they're still pseudo-random, they're just a lot harder to work out and work backwards from. But this one, because we can use it with a set seed, because we can get deterministic values out of it that are somewhat random to cursory examination, we use it for procedural generation. What it means is that we can send the same seed in and get the same input, we send the same seed in and get the same output out every time. Now, the problem will be is that if we change this, then if we do another, say if we rolled twice in here, we rolled for two different properties, that would completely change the generator because you're hitting random twice. We can work around that and we can figure out some other ways of doing things down the line, but what this really means is that for now, this will give us the same thing over and over again. So there, thanks Kappa. Hello Kappa, welcome to the stream. Can you quantify how random a random sequence of numbers is? Kind of. What I would suggest, if you are interested in that, there are a good number of videos on YouTube. I believe there's a good number file video on it. If not, there's a computer file video. There are two very similar channels run by the same people. Computer file and number file. Computer file will probably be the one it's on because they go more into the computer science side of things. In fact, I will look it up just now to see if we can get that up. Where are we? Let's see. Yeah, so there is a computer file video on random numbers, and yeah, there's a number file on randomness is random, and there is a number file video on random numbers. So, actually no, they're both number file, yeah. So, it's kind of beyond the scope of the tutorial to go over how random a random sequence of numbers is, but you can basically put them on a graph and map the distribution, and that can tell you how random, that can tell you how random a set of numbers is. We don't really care how random. It's cool. We don't really care how random these numbers are for procedural generation. We kind of do. But for this one, all we care about is that if we put a seed in, we get the same sequence of numbers out the other side. So we'll go back into that. We now have our factory. So what we're going to do is we are going to have an I world factory. We're going to bring in world generation. Now, you can see the problem here is that we don't have access to this world factory because it's an internal class. So what we also need to do is a factory builder. We need to request a factory based on some keywords. So what we're going to do is, how can we put this? We're going to send in a request and it is going to pass us out a factory. So world factory So we're going to do a case statement for the generator type. Come on, give me my indentation just. So we go make that static. So we do that is how we get our factory. We need to set seed. So what we'll do in here is expose that to the inspector. And we will set the grid size. Again, we will expose that to the inspector. And again, the reason that we return the factory from each of the functions is so that we can do this. And what we can do now is create tile template of 0 with a probability of 10. And we just duplicate that and create a bunch of those. And build world. So that's us doing our procedural generation. Next, what we want to do is we give a public list of game objects with our tile prefabs here. And we will then map each of these IDs to them. So what we're going to do now is take that out. And do it on 2 lines. So now what we do is we do factory.get, set seed, set grid size, and then for each var tile in tile prefabs, factory.create tile template. Actually, no, that's wrong. For int ID is 0, I is less than tile prefabs dot count. Count. Why are you telling me int ID? And then our probability, we'll just set each of them to an equal probability of 10. Why 10? It's just a programming thing. 10 is a nice number that you can put things less than or above and put things in between without using floats. So if you go back to basic, the old basic line numbers, there's line 10, line 20, line 30, and then if you want to add something in the middle, you do line 15. It's that kind of mentality, and that's why we're using 10. You could just easily use 100 and have everything be 100, but we don't really need that just now. We're just doing this as a set probability, so we should have a grid of tiles that will be of a similar distribution on the field. So how do we call this build world? Well, we don't really call it anywhere just now. So we'll do it on enable. We'll build the world. Not doing anything with the world. The world is just sitting there. What we will do though is make sure that it actually runs. We'll attach to Unity. We'll use the debugger, that little plus at the top there. Now we are attached. We can see here we have a seed. We'll do a random seed 1, 1, 2, 3, 5, 8 because I like the Fibonacci sequence. We'll give it a 10 by 10 width, and we will add our prefabs in. Now, pro tip for Unity: click this button at the top right, this lock button. It will lock your inspector. So if you click on other things, that inspector will not change, including if you click on things in here. What we will do is we will select all of our prefabs. we will drag them over to the tile prefabs list. Bam! Populated. An entire world just sitting there doing nothing. Exactly. So now we unlock it, you'll see that we have all of the game objects selected that are in there. So now we have our 6 elements. We're setting it up as a 10 by 10 grid. I will hit play. And we have hit the breakpoint. Now this is just before build world. So let's have a look at the factory. Maximum probability set to 0 because that doesn't get set until the world is built. It has received our height. It has received our width. The RNG. It's very hard to see if it's set or seed, but I can assume it has. What else was in the factory? Tile templates, 6 tile templates. ID 10 probability, ID 0 probability 10, ID 5 probability 10. We'll go into here. We'll add another couple of breakpoints just so that we can go through it. So we'll add a tile. Again, type ID is 3. It's randomly generated at 0, 0. Oh! Apparently, I have buggered something up. Somehow, we got out of this. See, now we can do some debugging. Somehow we get out of this. Now, the maximum probability was set to 60. Our actual probability was set to 60, so nothing weird has happened there. We rolled a 44. How did we get out of that loop? That's how we got out of that loop. And that should fix it. This is the benefits to debugging and why you should always debug before every step of the way. This is why we didn't just go diving in to putting the stuff on the screen. Now, I'd love to say I did that on purpose, but I did not. That was entirely accidental and a good learning experience for everybody. The importance of continual testing as you program. There we go, we're back to there. We were just lucky that our original roll was low enough that subtracting 6 every time got us a roll. So this should still be tile 3. Interesting. It won't be tile 3 because we are rolling differently. Okay, that makes sense. So what we'll do is we'll go in here and this roll should be 44. The roll is 44. It should not die this time. Type ID 4. Type ID 3. Type ID 3. So we'll just let that run. And now we have 100 tiles in a 10 by 10 grid. That it does nothing with. So I'm fairly happy that that is working. Let's actually translate this into displaying this on the screen. So public void display world list I world tile. So what we'll do is we'll just straight in pass the output of that. We won't bother declaring another variable. And what we will do is for each var tile in world. What we also need to set now is the size of the tile. Does Unity have a Vulkan backend? I don't know. Vulkan's the iOS, isn't it? Or is that Metal? Which one's Vulkan? Unity, yeah, Unity supports DirectX, Metal, OpenGL, and Vulkan. But how do you use it? Yeah, Unity does have a Vulkan backend, but I've never used it. Most of my games are 2D stuff, and literally, I don't need to get into half of the graphic stuff. The best I've done is a few weird shaders. I'm not a graphics engineer. So for each tile in the world, we do tile dot type ID. We get var prefab equals tile prefab. We want to instantiate a new one. Parent it to this. New vector. Local position. New vector 2 of tile.x times tile size, tile.y times tile size, and this should display the world. There we go, there are our tiles. So the tile size is a bit big. I'll make it 0.1. There we go, that's a bit better. We'll move it down a bit. And we'll make that 0.2. Give it a little bit of space. There we go, that's a bit better. So that's our tiles, and if we want to, we can see how the random distribution goes. We'll do some analytics on it, shall we? So, public void just because you asked about how we quantify how random a sequence of numbers is, what should happen is that there should be roughly the same amount of tiles of every colour, because there are 100 tiles and we have 6. We have 6 different permutations. But one of the ways to analyse it is to see the distribution of it. The other is to see how often it rolls the same number twice, because truly random numbers should be rolled truly random. The previous number shouldn't affect the next number, but because it's pseudo-random, it does. So how random the sequence is, not that if there are more identical numbers, but if there are enough. Again, I'm not a mathematician. I'm a math fan. So we're going to do some select. I'm going to bring in link world.select. So I'm going to get the type IDs. Possibly. It's certainly the way that the random number generator works is that eventually you'll get to the end of the list of numbers and it'll look back to the start and do it again. I believe that the random class in .NET, you would have to count for donkeys in order to get back to the start. But there are ones out there that you can get that will deliberately do that. But don't ask me about those. There are reasons for wanting different kinds of pseudorandom number generators that do generate repeating patterns more often. But for our use here, we just want bog standard built-in randomness is completely fine for us. Randomness is a great topic to go into. It's just I'm not professionally knowledgeable enough about it to go into any depth on it. I have just enough knowledge to be dangerous. So we're going to do the type IDs and type IDs dot distinct. We'll take that out actually. So we're going to get the number of distinct IDs. So for each are so we're literally just going to output the count. And that should see a reasonable distribution. Like, there shouldn't be too much. On a scale of 100, there might be 2 or 3 different. So we go 14, 15, 21. Yep, so the lowest is 14, the highest is 21. 15 to 16 in the middle. Yeah, and all of them are accounted for. So what we can also do is we're now going to go one last thing before the end of the tutorial is we're going to add in more probabilities. So right now we've just set the probability to 10. So public what we're going to do is we're going to change tile prefabs to this tile probability class. We're going to need to start, we're going to need to drag them in, but what's going to happen here is that we're also going to do tile prefabs, pass in that probability. We go back to Unity. Now, we're going back to that. We'll now see that this is not quite the same. We need to add in our tiles by hand now, unfortunately, because it's not a list of game objects. So we'll make it so that black tiles appear 10 times more often than everything else, and white tiles appear less often. So we should see a sea of black tiles. As you can see there are 71 black tiles and around 5 or 6 of everything else, and white tiles appear 3 times, which is a lot less than the 6 average, which is half less than the 6 middle, and they appear more than 10 times more. So there's the range of things. So what we can also do is we can change the seed. What we'll also do, actually, now that I think about it, is that we want to be able to change this on the fly rather than clicking play all the time. Show you something else in Unity. Context menu, rebuild world, create a function like that. What that will do, it's called build world. It'll also clear all the children that we've already created. So for equals this dot transform dot child count, I is greater than or equal to 0, I minus minus this dot transform dot get child I. We destroy that game object. So that we can just start rebuilding the world while we're in there. So we'll do that. Click play, because there's a little bit of a delay. We can fix that, but we're not doing it just now. So we'll change the seed. We'll just bung the seed up a bit. And now when we do that little dot menu, rebuild. Transform child out of bounds. Buggering bollocks. Why did that do? Oh. That's why. Kind of. It's always going to be that. No, what happens... So I went over this in a previous tutorial, but Unity has these experimental play mode settings. Now, every time you hit play, it will reload the domain and reload the scene. And reloading the domain is the thing that usually takes the longest time. What is the domain? The domain is your whole body of code. So it won't rebuild your code. It takes your code, it loads it into memory, and sets all the default values, etc. What it does every time you click play is take it out of memory and put back in a fresh, clean copy, which is good because you want this to be as fresh as possible. The problem is that it's really slow. So when you take out reload domain, so if you click this button, you want to reload the scene because that's not that bad if you're on small scenes. But reload domain, so if I save this and just hit play, straight away, because I'm not reloading the domain, straight away, instant. Why is it experimental? Because you're not reloading the domain, it's not resetting statics, is the big thing. There are other things that it doesn't do when you reload the domain, but the statics are the big one. So if we go back into the code, you'll see here that the static that I created here is a function. That's fine. That's fine. It was when I was doing the Singleton tutorial. Singleton likes to use statics a lot. And what you end up getting is dereferenced game objects that are static, or components that are static, that are still in memory, and Unity throws a wobbly whenever you try and access those and goes, no, don't do that. And there's a whole tutorial on what you need to be careful of, or a whole part of a tutorial that you need to be careful of when you click this button and you start doing code. So it's best to leave it off unless you know what you're doing. But it's useful. So anyway, what were we doing? We were making sure that this works. So this works now. We'll reset the seed, rebuild the world, and see it changes. Same seed, different number of black tiles. We'll do 0 black tiles. This should actually show no black tiles. And this should just be a sea of yellow. And this should throw an exception. Viola. So, because we're rolling 0. So that's an expected. Rebuild that, we get blue with a little bit of things. So this is the basics of procedural generation. This is kind of the meat and potatoes of how things work with procedural generation. You need a random number generator, you need to set a seed. The factory pattern is incredibly useful for it, like really useful. The core concepts behind procedural generation really help you understand a lot of general computer science and engineering concepts. So one of the things that I keep seeing, so if you go on to a developer Discord or a Reddit forum or any of the other help forums out there, like God, what was it? There's a whole bunch of developer forums out there that have been around for decades. If you go onto there, a lot of new developers, not just Unity developers, like Unreal developers, people making their own stuff, I see a lot of problems people have is separating out the concerns. Separating out data from visuals, separating out, especially in Unity, separating out the game objects and the stuff that you put in the hierarchy from the actual data that you have in C#. It helps me coming from a web development or a web development, a web software engineering background, doing databases and full stack web development, that the separation of concerns is forefront in my mind, because you have your database off on one side and you have what you send to the user off on the other, and in between you have all of the logic and all of the stuff that effectively builds the stuff that's in the database into an HTML page and sends it out. Coming at it from that, it was a lot simpler coming into Unity and figuring that out and seeing that as being one of the main things people seem to have problems with, is this detachment. Because a lot of people just come in and go, right, this world builder controller, I want to build a world builder controller. Everything that's in this factory, everything that's in this tile, would just be in this one monolithic controller. And it would be how can I put this? It would just be a clusterfuck. Like, it would be impossible to read, it would be impossible to debug, it would be so hard, like coming back to it in like 6 months' time after you've not worked on it is just as bad as someone new coming onto the project. And you'd be like, I don't understand any of this. Now, the one thing that I haven't really done here is comment much of this. Comments are useful. Don't over-comment. This is probably over-commenting right now, but so long as you use decent names for things, so long as you use so long as you don't use variable names like A or X or things like that. And now I know, for example, there is a T there, but it's type IDs, it's a lambda expression. You're going to understand what we're doing. So comments when your stuff is verbose, when your function names are descriptive, less needed, but still useful, especially if you get to a point where you've done a weird change. Comments are useful, but don't over-comment. That's a bit of a tangent I went off on there, but I tend to do that when I'm getting to the end of a tutorial and I don't know what to say. So that's a good point as any to end the tutorial. We have ourselves a procedurally generated grid. We have ourselves something that somewhat analyzes it, and we have a way of setting the data. So you set the data, you pass it off to the worker, or the factory in this case is the pattern that we're using, the thing that works on the data. It then sends that back to the thing that requested it. The thing that requests it then sends it off to the renderer. Now, in our case, our world builder controller is also the renderer, this display world function. In a perfect world, or in the next tutorial perhaps, we take this display world and we put it into our own display thing. So it doesn't care where it gets the world from, it just knows where to put this world. And it knows what to do with it, because we'll get into a bit more complicated stuff. So all we're doing with this prefab is we are setting the parent and we're setting its position. You may want to do some more processing on that once we've got all the data from the world builder. But for now, it's quite happy just sitting here in the controller itself. So next week, we'll be continuing this series. We've done the basic factory pattern. Next week, we'll be doing some actual procedural generation. And when I say actual procedural generation, I mean we're going to do things that isn't just roll some random numbers and display that on the screen, which is what this is. As you can see from this, we could quite easily build a dungeon. Well, what we're going to do is we're going to start doing a little bit of graph theory. We're going to start connecting these rooms together. Hello, me neither, I don't know. You have come in at a very inopportune time, as I am just about to end the stream. But welcome. You can go and watch the VOD for this whole tutorial. It's about an hour long now. I will be putting it on YouTube as well. But thank you for coming. It is good to see you. Someone always does it. Every time, someone always comes in at the end. But welcome. Thank you for coming to the stream. This is what we have gotten out of our tutorial today. So procedural generation with a factory pattern. Some nice bit of interfaces. Some nice tangents. But it has been fun. Thank you for coming. Thank you, Kappa Votes, for the questions. I'm sorry I couldn't answer all of them. But thank you for joining me. And look up those number file videos on random generation. They are quite good. Not that math heavy, and should give you a better understanding of exactly what randomness is and what pseudo-randomness isn't. But until next Thursday, when the next tutorial is, thank you for coming. I will see you then. Next Tuesday, I will be playing some games, because, you know, this is Twitch. We're supposed to be playing games at some point as well, not just making things. Creative was a mistake, wasn't it? I will be playing some old retro games. I will probably be doing another Dizzy speedrun. I do have some actual proper games I want to play at some point on stream, but I haven't got around to doing it. But next Tuesday is Retro Tuesday, and I will see you. Well, I will possibly see you all then if you want to join up and see me playing an old Spectrum game, or a new Spectrum game rather. But next Thursday we'll be continuing with this and getting a bit more in depth on the procedural generation part as opposed to the factory method. So until then, thank you for coming. I will leave you with some music.